This is the Empower Podcast. Released May 15th, 2022. Episode 589. Mute Button Discipline.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
We're fighting to see who can maintain their ability not to cough for this entire episode.
Yeah, discipline. Mute button discipline.
Mute button discipline. Okay, it's the new terminology.
The name of the game.
All right.
Yeah.
Yep.
When both of us are maybe a little under the weather.
We are both recovering, so yep.
Yeah.
Oh boy, this will be good.
Yeah. Yeah. Well.
All right.
I've got a lot more of this ahead of me.
Yeah.
little kid in the house, a lot of snot.
Yep.
A lot of things being transferred to the parents.
Dragging in from the real world. Sorry.
Yep.
They're a germ factory.
Mm-hmm. Yeah.
One of the things we could embarrass ourselves over.
Let's start there.
Yeah. Not knowing about beta.
Yeah, that's right.
However you want to pronounce it.
So before the show, I sent Dave a link and I was like, Dave, make sure I just don't have any clue what I'm talking about here. And we were like going through this thing, and so it's the Falstead simulator, which you've used before, right?
I've used rarely. Yeah, it's one of those online ones, and I think it was the first one to do the graphical flow where it actually shows you the physical electrons moving back and forth and all that sort of jazz. I think it was the pioneer in that, but please leave it in the comments.
Yeah, I mean, I love it for that. Just being able to see like some motion and like you can see when a channel is opened up, especially for like dynamic circuits, it's really, really useful, So, and you could slow it down, speed it up, whatever. Really, really quirky interface. But, as a free resource, I mean, it's basically this and LT Spice and a couple of other free ones, but I'd put this up there with LT Spice, different flavor, right? I think probably a different.
Oh no, totally different
level of probably. This might actually be less quirky than LT Spice. I'm not sure.
Yeah, I know. They all have their individual things,
but the accessibility can't be beat. I mean, like I sent Dave a link for this versus like a text.
Exactly.
So that
I know.
Anyways, and if anyone knows the Falstead people or person, we'd love to talk to them. I tried reaching out once. I never got through. So anyways, I was helping a student with a MOSFET circuit. There was a drop that neither I nor my student expected across a MOSFET, a P-channel MOSFET. And so tweaking all the different values and playing around with things. And I'm like, this doesn't seem right. And so you click into the part, you see all these different things and the different dialogues that are there. And there's a variable in there called beta. So you double click on a P-channel MOSFET and you see beta. And I was like, I don't know what that is, but you just kind of assume it's right, like at first at least.
Right.
And then I noticed that the beta is a link and it takes you to a calculator. And finally, when you get to the calculator, it says actually the default value is small, which is for a small signal MOSFET. But for a power MOSFET, which is what the case, I was putting about an amp through this thing. So that's definitely MOSFET power territory. Use a larger value like 80, or you can go and calculate your own. And so before the show, I was like, Dave, is this a value I should know? Because I know beta for a bipolar transistor, but like a MOSFET, I don't know, like what the hell is this thing? Like, am I just completely missing this part of the textbook, or like what's going on?
No, I was the same opinion that no, beta is a function of bipolar transistors. In fact, its definition is current gain. Right? It is the thing. I mean, that is the difference between MOSFETs, FETs, field effect transistors, and bipolar junction transistors, BJTs. One is current. I know there's a lot of fanboys who will rip us a new one for this, right? But BJTs are current-driven devices and MOSFETs are voltage-driven devices. Now, I know all the physicists are going wild and,
It's all fields, Dave.
Right, yeah, it's all fields, exactly.
We'll get to that later.
Yes, we will. There's a segue there.
Yeah.
But, beta is not your standard parameter of a MOSFET.
I think more to the point, actually, for the bipolar thing, even if, however you want to think about it, if you start from voltage, you start from current, I think that as a mental model, many people start, I know at least I did, I started thinking about transistors as voltage controlled devices, or BJTs as voltage controlled devices. And I think that's way too confusing. And starting to view the world from the current perspective is very, very helpful in that way. So,
yep, I totally agree.
But in a MOSFET, all that current goes slamming right into that one half of the capacitor, at least in my mental model, and it doesn't flow anywhere. So yeah, beta doesn't make any sense here. So we were like, oh, what the hell is this thing? and so searching around online, you just type in MOSFET and beta, and the first link that comes up is Falstad. So it's like, okay, well, maybe a little circular there. It seems like it's kind of like coefficient built on top of transconductance, but it's not called transconductance. But
yeah, we've spent like less than 5 minutes on this. So it's like we have not comprehensively researched this topic. But for some reason they use it in their simulator. It's like it is the major parameter. There is VGS, isn't it? There's VGS and there's beta, and that's it. They're the two settings you can change for the MOSFET.
Yeah, I think you set the threshold as well, right? So you would.
That's what I'm talking about. The VGS.
Yeah, but I think the reason they say VGS is they want the threshold to be different than what the gate is actually spec'd at, because usually an RDS on is at some voltage, right? So it might be at 10 volts if it's an N-channel FET, or minus 10 if it's P-channel. And so like you'd have a different current at that what your RDS on is at. So yeah, it seems like kind of like a back calculation of that.
See, it doesn't even give you a value for the RDS on. Whereas, if you open something like LT Spice, right, it gives you your VDS, your RDS on, and your gate charge, right? They're the three major parameters you can set for your MOSFET. And I'm just amazed at how different they are.
Yeah, I feel like it's tricky for young players, young and old, because sometimes in like a LT Spice, one of the things that I like about it, but also I hate about it, is that you can go and pick an actual part number, right?
Yes.
And so if you have your actual part there, it's freaking fantastic. It's like, oh, great. It's already been modeled for me. I'm good to go. It's got like, there's more, if you look at the model, like a model of a FET, there's like a dot model, and then they actually have different parameters they can put in there.
You can go as deep as you want. Yeah.
Yeah, exactly. Right. They can basically tweak the curves to look exactly like the curves would look like on a FET, on your specific FET even, which is awesome. Now it's like, all right, now we're zooming back and saying, well, what's the rough curve here, and then back calculating. So that's what I assume beta is some curve definition that they're using. But at the end of the day, it doesn't really matter for what I'm doing. It's basically like, oh, no, exactly. It's slammed all the way on.
Is there current
What's
there?
Your RDS on?
It's not.
Yeah, exactly.
You aren't simulating the THD of some
that's right.
high-end audio MOSFET amp. I'm
that's
with
right.
your Falstad simulator.
Yeah, I wouldn't recommend that. That's probably not not the program for you. Yeah, there's so many other weird quirks about it too. Like, so it's JavaScript based, so like that's the best part. It's in the browser, stuff like that. And there's other JavaScript based ones out there that are built on top of there's some Spice engine underneath, NG Spice or whatever, P Spice. But the quirks are just like, man, I looked for like a half hour, be like, how do I rotate a part? Yeah. The way you rotate a part is you redraw. So if you want to, if you're in the simulator right now and you hit uppercase N, which should draw an N-channel MOSFET, and you click and drag, you can drag it in 90-degree directions. That's the only way I found that you can rotate this thing.
Right.
So it'll like pivot around a center point, but that's the only way you can do it. And then it's like, okay, well, what if the drain and source aren't in the right orientation? Well, you place it in the direction you want. You double click on the part. You say swap drain and source, so it flips 180 degrees. And so it's just like, all right, well, I'm playing in Mr. Falstad's world. Dr. Falstad, I should assume. Dr. Falstad, I presume.
I did find a reference to beta in Spice, in LT Spice models, to do with N-channel JFETs and also MESFETs.
MESFETs.
So I just
Which
I don't know.
Quite a MESFET, isn't it?
There you go. I'll send you the link. It's like, I just don't know. I don't, Spice.
Yeah.
Nomenclature. I can never say that word.
Yeah.
Yes. Spice parameters.
Yeah. You know, so then like I click on a page. So actually, I just Analog.io is like a newsletter that's out there, and they posted a link to like this 1990s like reference of like it was like a professor's notes and a textbook basically, and it was like available online. And it was like this unsecured HTTP site with just like a bunch of like Word documents. I'm like, this is a pile of viruses waiting to happen, and yet I want the knowledge in here. And you know, like I don't know, like you see all this stuff online too, and it's just like, oh, boy, I hope this is right. I hope there's no malicious people that like making like making nonsense equations in whatever the hell that equation language is, LaTeX.
Oh right, yes, the yes.
To like
that's the online that they use on forums and all sorts of stuff.
Yeah, it's like the Markdown language to make big square roots happen and stuff like that. Yeah, yeah.
It's fancy pantsy. Yeah,
yeah. I think the only thing that saves us is like, who would do that? That's insane.
Well, it's going to be a great troll if somebody does. You know, if you're like, you know, you can pretty much like own the Google search terms for a certain weird thing. You know, it wouldn't be that hard.
That's some deep troll. That's some deep troll right there. Oh man. Why? Just imagine you're closing the book 6 a.m. ready before your final exam for an electronics class, and you get to the bottom and it's like, none of this was real. Devious.
Well, you want to know what else that may or may not be real?
What's that? Is it fields?
Fields. Current flowing energy flow inside or outside of a wire.
Dave, you got a huge shout out, I have to say.
Oh, I got a little one.
I mean, you were on screen on a Veritasium video.
Yeah. Actually, there is an hour's worth of footage of us two talking about this.
You and Derek?
Yes, me and Derek. Cool. Yes, yeah.
Cool.
For those who don't know, he was actually planning this video before Christmas time. That's when I met with him. I think I was the last one that he contacted just before he was going to release the video at Christmas time. And for those who don't know what we're talking about he's finally done a follow-up video to the infamous, transmission line to the moon switch light bulb thing.
How fast does the light bulb turn on?
Yeah, we've talked about this previously, I'm sure.
That's right.
Anyway.
Yep.
So he finally done a follow-up video. But he actually was going to release this before Christmas time. And he frantically called me up just before Christmas. I think it was Christmas Eve or something. I'm not sure.
Oh wow!
And he going like, I'm going to release this video. I'm not sure if I'm going to release this video. I'm not sure. Like he genuinely was. Sorry.
That's when it came out? Is the original?
No.
The original came out then?
No. The original came out. I don't know, early December, maybe. I can't actually remember.
Huh?
It's been a while now.
Okay. Oh, so you're saying so the original came out in December. Then he called you towards the end of December after he talked to a bunch of people.
Yep.
Then he was going to post this most recent video, which is Derek talking about or doing an experiment where they actually do a transmission line. They measure the responses. They do some simulations. Yep. Great. I thought it was a great follow-up.
Oh, it was excellent. It was very.
It helped me understand it actually a lot better. That
yep.
I don't remember the YouTuber who did a simulation, but that was really.
Yep.
It was like a field simulation. That was really cool.
Yes, it's great.
Yeah.
That was Alpha Phoenix, which is another another YouTuber. Anyway, it was released on November 20. So, geez, it's a while ago now.
Mm-hmm.
And he only just got around.
Dave missed his cough button.
I did. Sorry, I lose. Hang on.
Yep. Wah, wah, wah.
All right, I'm good to go again.
To be fair, he was talking a lot there. To be fair, Dave talks a lot.
Anyway, where was I? Yes, so frantically called me up because he was so worried that he wouldn't make everyone happy because he genuinely wanted to explain it the way he originally He wanted to, like, he was, he discovered well, he didn't just discover, but he wanted to share Poynting's theorem with the world and everything.
Yeah, right. That was the basis of it. It was like, look at this cool thing.
And that was the basis of it. Energy flows in fields, right?
Yeah.
And it's like, yeah, of course it does. Yes, right. Everyone learns this. And people thought, including myself, I thought maybe he's trolling with the moon question, right? Because maybe he's trolling us engineers. But I'm absolutely confident now, after talking to him about it, that no, it was just like he just wanted some example that would look good and to Joe Average on screen, right? And he didn't give any thought to how it would rile up all the engineers and cause this great controversy, because Poynting's theorem is not controversial. Right, energy flows in the fields, right, and it's just like bread and butter kind of stuff. Even though us engineers tend to ignore it most of the time, right?
In
totally. Fact,
up until you get a board back from the board house, and you're like,
and it's
this controlled impedance line is not doing great. This just failed emissions testing. All right,
oops. And as I said in my video, even Feynman himself, right, went, well, you don't really have to concern yourself with the detail of whether or not the energy actually flows in the field or not. It's pretty academic, right? It doesn't really matter that much, right? That was basically paraphrasing Feynman himself.
I mean, it's all mental models, right?
Yeah, exactly. It's turtles all the way down. So, yep. And so So I thought he was not ever going to do the video, because I thought, look, it's April now or whatever. And well, that's May now, but it was the end of April. And I thought, no, I think he's abandoned the video, because he said to me, I think I might scrap this. I think, like, because I've done all the measurements, I shot all the footage, I built the thing, went to a lot of time and effort to build the whole, he built it on poles, giant poles. You had to construct these poles, paid a lot of money for the copper pipes and everything.
Did he do this? It looks like Stanford. Is he at Stanford when you recorded that?
Yes, he's there. Where he basically isn't there anymore. I'm not sure if that's but anyway, he's not there anymore. And that's so he got all this footage. He measured it all. He got his $100,000 scope up the top of a ladder.
I'm not sure. Oh my god, that was the worst part of that video, where I was like, I know. Oh god,
it was very triggering. I'm here all week. Yeah. Anyway, I thought he wasn't going to release the video, but sure enough, he did. And it's an excellent video, but it does not stop the people arguing. In fact, it's been hilarious to watch the EEV blog forum over all this time, over the last 5 months or so, right? Back when his first video was released, there's like an 80-page forum thread on this. And if you dared to even hint at maybe suggesting that energy might flow within a wire, right? You were hounded down by the Poynting fanboys, right? You were absolutely pounded into submission by the Poynting fanboys. It was hilarious.
Pointed fingers. They weren't afraid to point fingers.
What?
Pointing fingers.
Oh, God.
Pointing.
Yep,
Pointing.
Whoosh.
Yeah. Okay. Sorry. Yeah.
Whoosh.
Yeah.
Yep. And and it was absolutely hilarious. And now it's basically flipped. Now there's a second thread, of course, for his new video, but also the old thread was basically overtaken by a bunch of people, like less than a handful of people, who basically, no, it's wrong. Poynting is wrong. Energy flows in the wire. And it's been almost complete. It's flipped itself on its head, and it's been overtaken by these people who swear black and blue.
100 years ago, you had to mail papers with evidence and all this stuff back and forth and in journals. And now you can just get on a forum and shout and shout.
Yep.
Isn't the internet wonderful?
It's great. I think the Poynting fanboys have given up. Trying to, go blue in the face to try. Anyway, so it seems like the energy in the wire fanboys have won on the EEV blog forum. It's hilarious to watch. Yeah.
Well, other things, I think it's definitely worth watching. Yep. Other thing he points out in the video is, which I'm not sure how much we've talked about on this show before, but Rick Hartley's videos. If people haven't watched, if you're doing anything like EMI, Rick Hartley is like the go-to. There's a bunch of like his Altium talks. Altium posted those online.
He was on there.
Definitely worth watching. Yeah.
I don't think though, I don't think that was. I thought that was one of the lower points of the video. Like, I'm a big Rick Hartley fanboy, right? So don't get me wrong, it was great to have him in there. But I think that
you thought he didn't make a good point with it?
I think he didn't make a good point with it, because if you actually listen to him and watch his slides, he's talking about high frequency transmission line AC stuff, right?
Yeah,
Whereas for me, the fundamental question still remains, and I still want it answered, and I'm still not 100% convinced, right? Even though I know the pointing and the Maxwell's equations and the math works out for both DC and AC. But my question is still this. I still have doubt in my mind that at DC
is a lie, Dave.
Pure steady state DC, taking all no switch bullshit, no nothing.
DC's a lie,
right?
It's a mental model.
Right? DC's it's a lie. It's a mental model.
There's a T-shirt in there somewhere. I don't know.
Right, there has to be. Yeah, it's like, what happens at DC? Like, if you've got like 100 millimeter diameter bit of copper, right, cable, 100 millimeters diameter, and you're passing 1 milliamp through it to a load, steady state, are you telling me that 0%, absolutely 0% of the energy flows within that copper wire? Yeah, it just does, like, giving that mental model in my head, and I put this on the forum and nobody wanted to deal with it.
Yeah, that's outside the experiment that he talks about too. I think that's the important
piece.
Oh
yeah, no, totally. His experiment is all about transients, right? Yeah. And totally, and that's why there's half a dozen different ways to analyze transient circuits like that. And that's why I did my video with, look, here's how a regular electronics engineer who doesn't give a toss about pointing would analyze this. And it's the cable capacitance. Basically, he admitted in the video that, yes, he actually showed the exact model I did, and the lumped element model.
Yep.
And how, yeah, this is another way to analyze it. And sure enough, yeah. And it all works, and it's all hunky-dory.
It does make you wonder, so if we didn't have the lumped element model, how would our jobs would be a lot tougher?
Oh, I'm sure we wouldn't have gotten to the moon, if we had to solve solve Maxwell's equations every time we wanted to power a LED or something,
What's the vector? What's the vector, Victor?
and then on top of that, you've got quantum mechanics.
Yeah.
Right? You've got quantum field theory, which was what Feynman won his Nobel Prize for, basically.
Yeah.
And he wrote the book on it. And what that actually means. And if I bring that up on the forum, nobody wants to deal with it, right? Because that's outside everybody's wheelhouse, right? And I just don't know.
Yes,
but I
I mean, it's electronics forum. You go to a physics forum, maybe you'll get some takers.
Yeah, probably. But anyway, I am actually still on the fence at DC.
Okay.
I have an open mind. I know the math works out. I know the point. I do not debate at all that the maths works out for Maxwell's and pointings at both AC and DC, and that you can analyze it using energy flowing in the field at DC. I have no doubt it works out, but I'm just saying there might be something that trumps that in the future, and I can't rule that out.
Yeah.
There's a niggling feeling in the back of my mind. And it's just easier. Like at DC, who the hell wants to deal with Maxwell's and pointings at DC, for goodness sake?
Yeah.
Get a grip.
Sometimes it trips me out that like a resistor, the resistance is just like a made up ratio, man.
It's all meta, man.
We should just like all get along with components.
I have a feeling that we're not sufficiently under the influence of enough drugs to truly understand it.
Take some cold medicine, just like
I think we need some. Yeah, I think we need some good stuff. Yeah, I think they had it right in the 60s.
Yeah,
you can just picture Feynman with tripping some acid. Whoa,
yeah, seriously. Yeah. Get some bongos out and just
yeah,
groove.
exactly. Yeah.
What if we pick some locks and we just like chilled out and played some bongos,
drove a hippie van coast to coast and just yep, I'm sure we'd figure it all out. Oh boy. Yeah. Oh, it's hilarious. Anyway, it was an excellent video by Derek. I thought it was very well done.
Yes.
Yep. End of story, I guess? No, it's not.
Speaking of EMI experts, we have another link on our forum about past guests, Eric Boagatins. He did a recent thing about circuit design rules and stuff like that. You know, the usual Eric stuff that I keep watching because it's always good. And
I'm sure he's another Energy in the Field fanboy.
Oh, interesting. Yeah, maybe we should do a little roundtable.
Guaranteed he is.
Him and Rick.
Yeah, have to be.
Duke it out.
That's his business is it's his freaking transmission
cash
lines,
money,
right?
Yeah. Yeah.
Yep. But DC. Sorry.
So, I've been doing this simulation, and then other times I've been in the code realm, Dave, and it's scary.
Come back to the hardware, my son.
Yeah. It's nice. I've been learning a lot, and that's been one of the most exciting things about my new gig. But one thing that like I had been coasting on for a long time is that I didn't have any like debugging capabilities in like in a real-time operating system. It was kind of just like, well,
right, okay,
everything's probably going okay because I can I see a print message and it's probably connecting to the internet, and there's connecting to the internet, that's good. But I didn't really like figure that out. But I finally figured it out, and that was very good. It's a critical step to any coding journey, which is getting the step debugging working. Because
cool bananas. I still have no idea about anything at all unless it's C on a microcontroller, C or assembler.
This is C on a microcontroller, actually. If you didn't, if you didn't know that.
Okay, but when it starts,
that's the crazy thing.
Yeah, but when it starts involving anything like web enabled is what I'm talking about.
Yeah.
I have no idea what.
I think that's the hard part of all this stuff is like, okay, so now you got like all of these competing interests, so like, and if you think about like how the computers that we're talking on right now, right? They're at the end of the day, they have a core, multiple cores, right? But it's still scheduling. An operating system is like scheduling tasks and interrupting based on inputs. If you have hardware interrupts and stuff like that, it's all the same thing when you shrink it down to a microcontroller too. It's just usually you don't have the same like memory management module. That's like the big definitive difference between like a Linux system and a embedded system. I feel like I should edit myself there because I'm not defining an embedded system. If you listen to the embedded podcast, they always that is a hot button issue. But anyways, so I'm working on tiny systems, microcontrollers that are talking to the internet, and most of the stuff running on this thing, I haven't written any of the code, and I don't really know what's happening. And so debugging will be helpful only because I'll be able to like figure out where things are breaking, and like usually within the stuff that I've written, that's like the important part. But
that's the only way I learn this stuff. Yeah, like I can get a microcontroller to talk to Wi-Fi and the internet and stuff like that, right? I can get it to talk to a YouTube API and, get a value back and, stuff like that. But I've got it, like, I can't write the code from scratch. I've got to take somebody else's code and put it in there and then hack it for my purpose. That's the only way I can learn how to do that sort of stuff.
I mean, I think sometimes it would be irresponsible to start from scratch, right? Like if you started from scratch today and you're like, all right, well, I have an Espressif chip. I want to write my own Wi-Fi driver.
Right.
And like do everything from the ground up. That's kind of irresponsible because one, if you're working for a client, you're going to like charge way more money than they should have to pay.
Yep.
And two, even if you were given that permission and you get to the finish line, you say, all right, now I have my very own bespoke Wi-Fi driver. And assuming there's no other reason, like there's no other requirement, like you needed to do something that the other stuff can't, and you validated that you really, really, really can't do it with the existing off-the-shelf code. It's like, well, how secure is your new thing? Because now you've just potentially created a very insecure, unless you know what you're doing, you've spent all this time and made this thing that might just be not that useful, and you have to maintain it over time. So, it becomes kind of a maintenance nightmare too.
That's what happened with the 121 Holdimeter app, right? Yep. We basically started from scratch. We were, well, how hard could it be? And we just both went, it can't be that hard, right? And no, like 12 months later, like it's just we should have just, we should have just given it to somebody who knew how to do it from, who's done it, 100 times already and has gone through that pain to like learn it all and stuff. And it was just a horrible process. So yeah,
yeah,
really sucks.
yeah.
Yeah,
It's
that was
tough.
a bad
It's tough.
choice.
Yeah. And so the thing I was extra excited about is, so we had Brian Amos on the show, and he wrote the FreeRTOS book. That was like a couple months ago. Really great
Yep.
book. Great way to learn about real-time operating systems using FreeRTOS, but like a lot of it's applicable to other, I think, real-time operating systems. If you're kind of doing more complex microcontroller designs and you're getting into the point where you're like, okay, I probably need more than just a state machine and stuff like that. Or if you're connecting the internet really at all, I think you almost certainly need a real-time operating system just to handle some of the timing and stuff. But one thing he talks about in the book that I hadn't gotten working with his book was System View, which is a Segur tool. And basically what it does is it listens to the debugger. Like, so as the debugger's like spitting back all of the trace stuff, it basically takes that and it's got some hooks in there that says, oh, I know where you are in your program, and your device just went into idle mode, and now it came out of idle mode, and now it's running task A, and here's your memory space. And like, you basically like, it's almost like a power analyzer. Like, and you could sync it up to a power analyzer as well, because, if you're running like a encryption engine, it's going to have it's going to use a lot more power than that.
Right.
And so that should correlate as well. But even if you're just not sleeping, you're going to be using a lot more power because you're using more cycles on the microcontroller core. Yeah. And you can just like kind of map this whole thing out and get an idea of like where your device is spending its time and how it's switching between tasks and stuff like that. And it's really cool. I mean, it's just like, yeah, it's not the only tool out there, of course. There's other ones.
Yep.
But yeah, cool
Nice.
stuff. Yeah.
Okay.
I have to put a plug in because I never understood, as I was like, moving into the microcontroller world, I didn't understand why debuggers were important. That sounds stupid.
Yeah, I know. No, I've never been able to. I do self-debugging with code. I just fill my code with
I mean, like printf debugging is a thing, right?
But like, exactly.
But I didn't understand like the analysis piece of the piece of hardware, the debugger, right? And like the fact that like the debugger is also, it's also the programmer, and like, okay, if you want to, not use a bootloader on this thing, then you need to be able to like access the single wire debug or the JTAG pins and stuff like that.
Yep.
I just really didn't have a good model. Like I kind of stumbled through it in my earlier days, and I'm getting a better feel for it. But I will say, I always was marveling at how expensive Segers are. Like Segur J-Links, rather.
Oh yeah, very.
They're really expensive. I paid, I think, $600 for mine, and it was like, you're using it commercially, you're programming stuff, like you're supposed to pay that, right? And okay, fine, I did it.
Yeah, of course.
Great. But then like all the other tools that are around is like, now I'm like, oh yeah, I'm leaning into this stuff. Like, it's great, So, go Segur, go other debug tool vendors.
Oh yeah, you can pay thousands and thousands of dollars for it.
Oh yeah.
Serious business.
Yep.
It's one of those things, if you need it, you really need it.
Yes.
If your back's up against the wall and, it's the only thing that's going to really show what's going on.
Yeah, exactly. And I think, I probably, I'm not going to be that person who's writing the Wi-Fi driver or the whatever driver that's out there probably. So I'm kind of on the edge of needing it. But like the people that are writing the Wi-Fi driver and like interacting with low-level hardware stuff like that, man, they really lean into it. So,
and then you can like integrate them all with logic analyzers. Like if you're at the, if you're working at Intel developing CPUs and stuff, like the tools that they have are just absolutely mind-blowing, right?
Yeah.
It's just
Cool. Yep. So So I'm learning little bits at a time.
Cool bananas. All right.
Yeah.
What else we got on today's list? What's been happening?
What has been happening?
Got some people buying out some other people. Yawn.
Yep.
No one cares.
I was just going to say there's fewer vendors, fewer board makers is probably less good, ultimately. Less competition.
Australia's expanded. We actually now have an extra board maker here. Woo!
Yeah, I remember you saying that.
Go Australia. Yeah.
Yeah. You did it.
Although we did have to steal it from New Zealand, but, sucked in New Zealand, but,
The Oceania region. It's fine.
Yep. So technically we didn't actually gain. It's still in the region. It just moved from Auckland to Melbourne.
Top the gap.
Oh, God. Imagine transporting all that crap. Imagine transporting like a wet, bloody acid production line.
We really should have taken the cupra chloride out of this container. Huh?
Oh God! Picture a regular lab move. God, this is like
Yeah.
all these hideous bloody. Have you seen these machines? Oh God, they're just.
I mean, they're just like big tanks, right?
They're just giant tanks, and shit splashes everywhere, and everything's got a rusty, corroded tinge to it, and it's just awful. Copper plated to the legs of the machines. It's just awful stuff. It really is. Yep. Oh God. Yep.
Well, speaking of moving shops, you're buying out a shop recently, right?
Oh, right. Oh, yes. I'm going to pick it up. Maybe today. We'll see. Yes, I got I got a whole bunch of auction. I'm going into the optometry business. I couldn't resist. There was this auction, and obviously it was one of these scientific warehouses, scientific surplus warehouses, who specialize in, buying and selling scientific surplus gear. So if you need a thermal incubator, or you need an analyzer, some chemical analyzer or something, they'll have one in stock, probably some used instrument which they got from the last scientific company that shut down, which bought it from them, and it's probably cycled through their hands like 5 times as these medical companies close up shop and sell off all their surplus gear and everything else. So anyway, one of these dealers, so they have occasionally, like, they have a mass clear out thing on an auction.
Yep.
I just happened to notice. Hang on, I might be able to get the names of the instruments. I cannot pronounce them.
Yeah, and I mean, so in optometrist, I think about like the little flip,
Yeah, no, not the flippy thing. We're talking about the new 3D eyeball scanning, camera made by Zeiss.
Got it. So you're going to be able to use this as like quasi inspection equipment almost.
Yes, and made by Zeiss, right?
Zeiss.
So I think I'm pronouncing Zeiss correctly. I don't know.
I think that's right. Yeah. The Swiss lens maker.
Yep. Anyway, so I have an anterior segment imaging system. Okay, it's anterior. I have a natural vision auto ref keratometer. A refkeratometer. REFKERATOMETER. Pronounce that one.
Mm-hmm.
A refkeratometer. I have a matrix visual field analyzer, and I have a Phaco emulsifier, which actually is not part of the it is part of the optometry thing. It's a laser eye surgery controller, basically. So I can send you, like,
what he's got, folks, is a lot more crap in the bunker.
Yeah. Got a lot of shit.
All right, so walk me through this. So, like, I was thinking about, like the optic piece is cool. I mean, like, this is all going to be cool teardown stuff if you end up tearing it down.
Yep.
But is that it? Is that all you were thinking? Is like,
no, I don't know. I just wanted it because they were going for a song, and okay. I don't, and I
feel too good to pass up.
And I just recently tweeted a fair bit about it, and I was actually going, and I did a poll on this, and I was actually going to contact. I had a complete 3D eyeball scanning session thing that went for like 2 hours, and and they used. I have my eyeballs scanned in 3D.
Are you sure they're not going to use it like in sneakers or equivalent, like to log in to some
cannot be sure
facility?
That Uncle Sam doesn't have it, so...
Yeah, that's right. Just immediately updates. Just goes to a...
Yep. Straight into the bunker under the...
That's right.
NSA somewhere, yeah. Now have my eyeballs scanned. Great. Yeah, and I just thought these machines were great. I went to, because the last time I went to the optometrist, it was just the eye flippy thing, right? They just had like the lens flippy thing they put in front of you. Yeah, you're blind. Here's some glasses. Go away, kind of thing, right?
Yeah.
So I thought, screw that. And my local optometrist shut down, so I had to find a new one. So I found a new one that has all these whiz-bang 3D eyeball scanning machines. And I went, well, that's got to be more better. So I went there, and I was just absolutely amazed. And I thought about actually shooting a video with him, and he wasn't against the idea that I'd go in there and he'd tell us all about his whiz-bang machines and stuff. And then like a couple of months later, here they are popping up on not his machines, but like similar sort of machines from Zeiss Optics and other, major companies just popping up on this thing. And I had to have them. They're probably not that complicated. They're just, I'm sure, like they're probably worth like $100,000. Right, if you had to go buy this Zeiss,
like buying it new,
if you had to buy it new, right, and somebody comes to your thing, a Zeiss man comes around and sets up your machine for you, and for you a couple $100,000, and I'm sure it's got like just fancy optics and cameras in it to take a photo of your eye, and some sort of flash to light the back of your eyeball, and then it's all software after that. Right?
Who gets sold some crazy stuff? Is dentists.
Yeah,
my good friend is an oral surgeon, and he said he gets absolutely inundated with like salespeople like waiting in his and because they're selling like really really expensive high tech stuff, because dentists have some of like the best 3D printers on the market, and like oral surgeons like basically my buddy like will not only scan your mouth, but he'll make jigs for every part that he's like cutting out of your mouth, and so like everything's just like all set up and ready to go. It's
wow. Yep.
I won't let him show me photos because I'm too squeamish, but like the stuff he talks about is insane. It's it's it is.
I'm sure it's in this field as well. You get if you're an optometrist, you get phone calls and people knocking on your door and hey, would you
it's a super high margin equipment, I'm sure.
Huge. Yeah. So I don't even know if the teardowns will be that interesting or not.
I mean, maybe you could just resell it. Who knows?
I don't know. It actually remains to be seen. Maybe. Yeah, I don't know. Anyway, it'd be very cool if I can get the optometrist to agree to do a like a please explain video. I think that'd be great. So anyway, I'm going to go pick up these things and hopefully we'll have some fun.
Cool.
Awesome.
That's great.
Yep.
That's great.
I just had to have them.
And
they just look so funky. They just look so good. They just like, like big chin rests where you put your chin and then this thing comes in front of your eyeball, and it's like, it's like, it's good stuff.
Yeah, it's funny too, because like you think about like the expectations around different types of equipment, and like an optometrist or ophthalmologist is going to be like, well, every piece of equipment has a chin rest on it, or an electrical engineer says, well, every scope has a probe input on it. Right. It's just like, oh yeah, it's like we just are like completely indoctrinated with like the kind of the user experience of these
usability of exactly.
Yeah. So look for a scope input on these things.
I've got something interesting next month that I'll be able to talk about next month in that regard.
Okay. Scope maybe?
Can't say.
Okay.
Can't say. All I can say is that there may or may not be a video already on my channel sitting there.
So all we have to do is
guess. All you have to do is guess
the link.
Guess the link.
Guess the 8-character hash at the end of
thing or whatever
YouTube
it is.
video.
How many characters?
Yeah. Okay.
Yeah. Anyway, yes, we might have something interesting to talk about next month.
Okay.
That's all I'm saying.
Cool.
Yep. What else?
So let's do a little update on bubblegum tap shoes.
Do we have to?
I mean, we should.
Well, let's milk it. All right. Might as well milk it more. Go.
It's still terrible.
Why is it still terrible?
I mean, you can't buy any parts. I mean, I don't know.
I can.
You can?
I've been getting stock. In fact, I did beat them off. I just had to beat them off. They were ready to deliver another 500 multimeters to me, and I go, whoa, hold on there. I just got 500. I just got 500 last month. You're trying to shove another 500 on me? What's going on?
Yeah.
Well, so I had to tell them to hold off. So It's a problem for some people. Sorry.
Yeah, it is a problem for me. It's not letting up in that way.
What can't you get?
Top on the list, I'd say the most stressful part for me right now is a microcontroller. I think I mentioned before.
Let me guess, it's an ST.
It's not an ST. No. It's out to March of 23. So
which one is it?
A little too long. What's that?
Which one is it? Come on, name and shame.
It's a Silicon Labs part. It's one of many that are out. I don't see any like coming back in though either.
Is this a personal project, work project? What is it?
This is a work project, yeah. But I saw actually there was an interesting question on a Slack that I'm part of, where they asked about, well, okay, say you're starting personal or professional right now, where do you start? Like, so what micro do you go and grab? Assuming that you don't have like super crazy peripheral needs.
Yeah.
Where do you go? Like, do you start?
Well, you could rule out ST, right? ST has got such a bad rep now due to the component shortage that there's almost no way you would start with them. Well, I don't know. I'd go back to like microchip. I'd go back to like old school microchip, maybe. Yeah, TI, maybe. Like other like, TMS 430s. Are they a problem?
MSP 430s.
Sorry, yeah. MSP 430.
I haven't used those in a while. Like 16-bit microcontroller. Yeah, I think some of it comes down to like what you need it for. So it's like if you're just like flipping bits, like got a UART and you've got some LEDs, like that's different than if you're talking over a satellite link or something like that, right? There's always going to be that, it depends, but even at the low end, I'm just not sure. Honestly, I think these days I would go onto. Actually, I think I do have an answer for this. I think I would start with Espressif these days. I have seen they have been extremely available, and I would probably even pick a module over a chip, assuming I didn't have power needs.
Yeah, but see, to me, that's not like a little jelly bean micro.
It's not. It's definitely not.
No, right? That's what I think of when I think of micro. That's more modular application, webby level thing.
Yeah, I mean, it's gonna, and it does make sense if you're. So first off, it depends if you're battery powered. If you're battery powered and you're like, I need this to last for longer than a week, it's like, okay, well, probably
right.
You're not gonna have a good time with this Espressif, or like it's just. But in terms of sourcing, that's what I've seen has been pretty reliable. Just because I think the modules themselves are so spread throughout the kind of rest of the ecosystem that it's possible to get them. But still expensive. It's not going to be like $1 each unless you're going down to a chip down solution. So I don't know. Yeah, it's a good question to have. I mean, like I think at the end of the day, you go search on a distributor site and buy as many as you think you're going to need and just start there. But man, that is risky. It's all risk, Dave.
All risk.
Yeah. Oh.
Oh boy, I'll pay that one. Okay.
Yeah.
Yep.
That wasn't intentional, but.
All right. Can we have a chip of the week? Chip of the week.
Sure. What do we got?
It happens to be an ST. Happens to be an ST Micro, but I mentioned this one on Twitter. Well, somebody else mentioned this one on Twitter, and there is a segue to this. It's the STM32F334, and I've sent you a link here, and it's actually kind of like a microcontroller specifically targeted at digital switch mode, power supplies, lighting systems, solar inverter systems, something that really needs fast, ultra fast analog to digital converter with low latency times, things like, a mains micro inverter that needs to track the mains, right? You've got to sample the mains and then track it and output and DACs and, things to right? You've got to, track and respond to things in real time. And that's what this microcontroller, it's got a high resolution timer in it, 217 puff seconds, none of that nanosecond rubbish, puff second resolution, right? Uh-huh. And which is also temperature and power supply drift compensated, by the way. And, it's got it's got an ultra fast 12-bit ADC in it, 5 meg samples per second, It's got ultra fast comparators. It's got 10 PWM outputs and all sorts of things, right? So you can get 217 picoseconds resolution in your variable duty cycle, variable frequency drives, right? It's just like, it's designed for, measuring things and controlling things really fast, right? It's just a really cool chip. Anyway, so this comes about because on Twitter, this is from Second Order EDA. No, sorry, 2N Order EDO. 2N Order EDO. And I think he might be the designer of the open source solar microinverter project. Don't quote me on that, but he seems to be involved. And I think this might be the micro used in it, because somebody was asking him on Twitter, why didn't they use like a new Raspberry Pi Pico microcontroller instead of this ARM STM thing? And he said, oh, no, I need the ARM STM thing because of the high resolution timer in it to be able to do the tracking and stuff like that. Anyway, so that's another thing we have on the link today, which is the open source hardware grid microinverter thing, which is really cool.
And that's the basis of this part is kind of integral to it.
Yep. So I think it is tied to it. Or yes, it is. No, they use the STM32G474, I think. Anyway,
so the
very cool.
So the F3, I always hear about F1, F2, F4. I had not seen the F3 family. I assumed it was there, but I hadn't. But looking for this part online as well. Are you seeing any stock? I see no stock.
Well, you probably can't get it. No, I'm not saying you can get it. No, I'm not saying to use it. I'm just saying. Come on, it's just chip of the week. You don't have to be able to buy the chip of the week.
Chip of the 150 weeks ago.
Right. Yeah.
Oh boy. Chip of the 52-week lead time.
Yep. Anyway, we will link to the EV blog forum thread to the open source hardware software grid solar microinverter 450 watt jobby microinverter. Looks like he's put a lot of effort into it, and it looks like a really cool hardware build.
Would you put this on your roof?
Don't know. Yeah, I don't know. Probably not.
I don't know when I would feel like. You look at like,
I know.
You're getting an inverter, you're buying an off-the-shelf inverter. It's like, okay, there's probably some certification there. There's no guarantee that like this is, this could be just as good or better. Like, I don't know.
No, it's a qualification.
But like, where does that mental switch happen?
You're paying for the quality. Yeah, exactly. I probably would not use it on the roof. I probably would.
Yeah, but when would you then? Okay, so now this thing goes to market. This is just like the mental thing that I think about. Is like, okay, so this looks like a very well designed product.
It'd have to be a mass adoption thing. It'd have to be everyone's using it.
Yeah, it's very chicken and egg in that way, right?
Right. Yeah. Of course, totally chicken egg.
Yeah.
Yep.
It's just tough to break into markets in that way, I think.
Because it has to be highly qualified. Like, it's these sorts of things have to go through all sorts of qualifications to be able to.
Yeah, when we had Paul on, what was he saying? Is there like a governing board for this sort of thing? He mentioned inverters, but I don't remember.
I don't know
what he said. Like if there's like an ISO standard or something like that.
I don't recall.
If people haven't listened to the Paul Zawada episode,
yep,
fantastic. Talked about power.
Yep.
Dave and I were clueless. We're a little less clueless now.
We'll have to get somebody from Enphase on, because I've spoken to the Enphase guys, and they were kind of amicable to, getting somebody on the show maybe to talk about, how these things, but they were telling me about the extensive qualification testing and just the amount of, thermal testing that they do on these things, and life cycle testing and shock and vibration testing.
Yeah, but that's totally different than like the testing is very different than the market perception, don't you think?
But it's only us that cares. Like Joe Everett, like if you put this thing in a schmick box and fancy, and you can be a one-man band and market the hell out of this, right?
Maybe. Marketing is expensive, Dave. I don't know if you know this.
No, it's not that expensive. You can do it. You just have to look professional.
No, I'm going to stop. I'm going to stop you right there. Marketing is very expensive.
Not for a niche industry like this.
Yeah, all right. I guess we're just gonna agree to disagree on this one, but
well, yeah. I kind of liken it to
I'd
my
not heard
Zappy.
of Inphase before.
I kind of like it, like I installed my own Zappy controller, right, for my car, It's my EV solar controller that actually tracks the solar and everything, right? And
cool.
I can, it's basically a bare PCB sitting in a fancy looking box, right? And if it wasn't for the fancy looking box, I would not get the same vibe.
I mean, most products are just electronics sitting in a box.
Yeah,
whoa,
I know.
Mind blown.
Exactly. Right?
This is Zappy, Z-A-Z-A-Z-A-P-I?
Z-A-P-P-I. Zappy.
P-P-I.
Z-A-P-P-I.
There's P-P-I. There's also a Z-A-P-I. Oh, it's a brushless motor controller. Holy crap. Oh, my God.
It's the Zappy, right? And Zappy, likewise, there is
creators. Wait a second. Inverter charger. I just want to make sure I have this in front of me.
Zappy 7 kilowatts, so you can see what you're looking at,
good.
right?
Yeah.
Right. It's a kind of funky big molded case, right? It's got an LCD and the cord wraps around the outside, and everything's hunky dory.
Oh, I see. The company is My Energy.
My Energy, yes. Right. Yeah, it's a UK company. And, like only a small company, right? They're not, this is not a big mainstream thing, right? This is a pretty niche kind of, thing. Oh, wow. Yeah, they sold thousands of them, but not millions, right?
Oh, wow. I know this doesn't actually matter for a product, but like if you go like halfway down the page, they have a Tesla plugged into one, and it is the worst Photoshop of a cable I've ever seen.
Really?
It's not even Photoshop. It's like an Inkscape. Yeah, it's like a render of like a cable. It's very fake, and then they put like a drop shadow going in the wrong direction.
Oh, right. Yes. Yep. I see it. Yeah, it's pretty bad.
Boy.
Yeah.
But Dave still bought it, so
Yep. I still bought it. Now, what is the difference between this and there is an open source one? Sorry, I can't remember the name of it, but the Open EVSE. Oh, so if you search for Open EVSE, right?
Okay.
And I think you can even get it, like some people sell it as a kit in a box or even fully. No, I think you can buy it fully built, right?
Okay.
You can buy it fully built, right? And it's just like, it's in like a see-through, it's got like an industrial see-through kind of case.
That's an off-the-shelf case for sure. Yeah, that's the drilled out like Hammond box or something.
Exactly. It's one of these off-the-shelf industrial IP cases with the big cable grommets on the bottom, right? Mm-hmm. And it just isn't. Is this better or worse than the Zappy? I don't know. I have no idea. In fact, we'll just say they're absolutely equivalent, right? And they can be programmed to do a similar job, although the Zappy's a bit nicer in its usability, apparently, just from a firmware point and an app point of view.
I know this is just, but I think the key point for me here is just that this is where you could have the best electronics in the world, but all that other stuff actually does matter. And I don't want to think about it, but it actually does matter. You know what I mean?
Of course it does.
Just for like perception and sales and marketing and all that other crap. It sucks, Dave.
Would I have been happy to buy this Open SVE thing, this Open EVSE, right? And even build it myself, right? I got the skill, it's a kit. But use this to charge my car at 7 kilowatts. And be happy to leave it charging overnight.
Your children sleep. Yeah, right.
Right? Yeah. It's like, maybe, probably, but the Zappy is just...
And then where do you fall on that spectrum as well? Like, like I remember you said when what's his name, Javier? I forget the one of the YouTube guys who does like DIY power walls. And I remember you saying but would you actually build one? Would you be comfortable building one? And as I thought of it, I was like, no, hell no. Like, no, God, same here. I don't trust myself that much.
Exactly. Exactly. Yes. Yeah. A lot of people ask me, they'll build your own do-it-yourself power wall. No, the hell no. I don't have the time to do it, right? And it's just...
I think some of it is like, it's perceived bigness as well. And it kind of ties back to the show last week when Lee was on the show. He related a phrase from his coworker, which is 2 people working in a team are worth 3. And I think that's kind of what I'm feeling in, like putting myself in this hypothetical, because I don't have this device. But like, if you have 100 people working on a device like this, there's more people checking it,
you feel more confident.
it's soldering it together, like and you could have like self-checks and stuff like that to build confidence as well. It's not the only way out, but
and as experienced electronics designers, we're used to building our own stuff. That's a no-brainer, right? We feel totally confident designing and building our own stuff. But I think we're both, because we're not power guys, both of us would shy away from anything mains or high power or, like power wall related or charging my freaking EV, right? It's like,
Whereas a photonic induction would probably be fine with it. He'd be like, that barely tickles, right?
Mike from Mike's Electric Stuff, he's probably, he'd probably, do it, no worries, right?
Mm-hmm.
But no, we're just wimps, right? I've got a wife and a family and a home, and I just want the...
Now, if I had an outdoor charging station like our mutual friend Martin Lorton...
Oh, yeah, totally.
Maybe I'd risk it then, right? He's got a shed where he's got solar.
Totally. I could
he does a lot of his own
stuff
as well.
That. Yep.
Yeah, but that's like a detached structure as well that like it burns down.
Exactly.
It's bad,
it isn't my house. Yeah.
But it's not my house.
While I'm sleeping in it. Yeah.
I have an attached garage, guys. That's thing.
Yeah, but that's also one of the things for the DC solar as well. Like as in the string inverter versus these micro inverters. These micro inverters, I wouldn't really have that much of a problem because they are only mains, whereas the high amperage DC string inverter stuff that scares the living crap out of me, right? Yeah. These things arc over, and they, just the switches catch on fire, for frig's sake, let alone the electronics, right? The switch, if a switch is responsible for thousands of house fires, a bloody switch, right? That's how, they were freaking recalled here in Australia. There were like 10 different brands of DC isolator switches recalled because of fire risk. A bloody switch.
Are there rooftop fire detectors for like solar systems?
Not that I'm aware of, but for the ultra paranoid,
that would be a good product idea.
There's a niche market, yeah.
That totally. Would be like a, especially if you could like tap off a line somehow and like make it powered so it's like always connected and whatever. But then like, because say you have a solar system with this high voltage, high current string, whatever, and it lights on fire. It's probably going to take a while to burn through your roof. But it'd be better to know at the beginning than at the end.
Right. It'd be better to know so that you can call the fire brigade and actually escape from your house. Before it. Yep. But before it comes through to the smoke sensors, which are actually in your room.
That's right. Right. Yeah. Then it's a little.
By the way, if your smoke sensor's going off in your room above your head, then you've got it.
There's smoke in the room.
Exactly. You've got a problem.
Yeah.
You haven't got long to get out. Let's just say that.
Yeah.
Yeah, so I would actually feel much more comfortable having my own mains micro inverter on my roof than I would my own string solar inverter.
Like a DIY version or self-built, if not completely DIY.
Okay. Yeah, I would feel safer. I feel safer having, but I've actually got a mixed system up there now, so I actually have both. So I've been debating whether or not we should actually go completely away from the DC thing. It's just not really worth it. Because buying a micro inverter for each one of my existing old panels is like costs more than the panels are worth, but then I wouldn't have that worry anymore of that DC, string bloody thing.
Maybe you should make a little fire detector thingy.
Right.
Maybe there's your next project.
Maybe. Okay.
Cool. All right. We figured it out.
What we need is an internet connected, Wi-Fi through cellular connected Internet of Things DC isolator switch.
Bingo. Who are you going to call? Chris Gamble. There's something on fire in your neighborhood.
It's a switch, and what it does is it detects whether or not it catches on fire, and it alerts you on your phone. Holy shit.
I mean, it'd sell. It would sell, man. You just got to work up a little FUD. Little FUD, and you're good to go. Speaking of IoT things, this is my last thing. I am giving a webinar next week on IoT system development. I don't expect anyone to really want to go, but if you do...
You do know engineers generally hate webinars, right?
I know. But, you don't have to like sit there. There's always the replay video.
Right.
This is actually for a local group called Riot, Raleigh IoT. I'm near Raleigh, which is Durham. Durham and Raleigh are pretty close.
Right.
And I'm doing it virtually, but it's actually a cool thing in the area. So
cool.
Yeah. I will tell people all the things they don't think about at the beginning when they should be thinking about them, because that's really when you get burned, when you don't know what the hell you don't know yet. So I'm going to try and tell you the things you don't know, and then you can go figure it out yourself.
Yeah. Awesome. That sounds pretty good.
I'll send it to you, Dave. I'll send you a preview link. You can just watch it whenever you want.
Fantastic.
All right.
Our AMP Hour's up. Catch you next time.
Talk to you soon.